All right. Can I get a volunteer for somebody who is feeling pretty confident after chatting with their neighbor to just tell me what you think the change is? Mayor, what do you think it is? You got 5. Okay. Did anybody else get 5? Did anybody get something different from 5? So somebody else, thank you for being brave, by the way. Well done. And that is correct. Can somebody else who got 5 explain to me how you knew that the change was going to be 5? And I appreciate you volunteering. I'm going to get someone else. What'd you get? How'd you get it? So you looked at this 2 and this 7, and you said from 2 to 7 is adding 5. And is that consistent? Is it behaving consistently? If I go from 7 to 12, am I also adding 5? And from 12 to 17, and from 17 to 22? All right, so we're pretty okay with how it's changing. I'd say you guys are doing pretty awesome right now. This is the trickier one, I think, in my opinion. Anybody want to be brave and volunteer what you think the start value? What do you think? You think the start value is 2? Did anybody else get 2? Oh, lots of people got 2. So it's got to be right if that many people got it, right? Does somebody want to tell me why they think it's 2? Why do you think it's 2? That is the key right there. The 0th figure. And this is why, and it may have seemed weird last Friday when you were drawing that 0th figure. It seems kind of weird to even say it 0th figure. But the reason that we do that is that's where we start from. In math, we always start at 0. 0 is the beginning. So the start value is 2. So if you knew to look for an x, and I love that you said x value too, because that's really what we're looking at, is an x value. Oh, it's frozen. My bad. So I'm sorry if you didn't, if this was frozen. Go ahead and put those little arrows with those +5s on them for a change. And then make sure you circle that first column there, that 0th figure. And it's that x value of 0 that tells us that 2 is the start. All right, you guys are doing awesome so far. Does anybody remember how to take those 2 values and y equals? I'll give you a hint. It's going to have a 5 and a 2 and an x in it. Judy, you want to give it a shot? All right, we've got a conjecture of y equals 5x plus 2. Anybody want to agree with that? Does anybody want to switch the 2 and the 5? Anybody want to go y equals 2x plus 5? No? No takers? That's because you guys all know that Jada's right. Good. Awesome. So when we did this, it was the change that ended up in front of the x, and then the start value that ended up at the end here. Can I get you guys to go into your green packets for me and find a learning log that says y equals mx plus b? We're gonna put some notes in here. And why is it really important to get good notes in our packets? You can use it on the test, right? So let's do. I'm gonna write this a little bit bigger. And I'm going to save some space underneath this because we're gonna write a whole bunch of stuff underneath this equation. But for right now, we've got one way to talk about M and about B. So we're actually going to add to this list as we go through the rest of the chapter because there's lots of different ways to look at this. And that's one of the great things. One of the things I love about math is that there's lots of different ways to view it and understand it. If you can make connections between those different ways, that just helps you learn it even better. But right now, what we know is that M comes from, was that the change or the start? M comes from the change. and B comes from the start. And you know what I think would probably be a really good idea? And you can decide whether you agree with me or not, but I'm going to make myself a little example off to the side here. And actually, this may seem a little redundant, but I'm going to put the same table, except I'm going to use X and Y that we just did. And I'm going to use this kind of as a quick example to illustrate how we would turn a table into an equation. So I'm basically just copying that work that we just did into here. Now these notes are your own, so feel free to use different words. I like arrows and I use different colors to kind of color code and help me see relationships between things, but that's not everybody's style. So you don't have to do it exactly like I do. But pretty good chance that when you get to your test here in 5 weeks or 4 weeks or so, that you're going to have a problem where you'll have a table and I'll ask you something about the change and start value and probably ask you to write an equation based on that table. I might even put a couple more notes. And this is my start value. What other notes can I stick in here to help me remember? I think this is kind of the key piece. You find the start value by looking for where X equals. There. I need to pass around. Where do you want to do that? Do the halfsy halfsies here. You get that half, you get that half. Thank you, folks. Appreciate you. What do you think? Is there anything else you would add to this? All right, so I'm getting a pretty good feeling, but again, I'm going to ask you guys to give me a quick temperature check how you're feeling about this right now. Can you just kind of let me know how you would feel right now if I gave you a table that looks something like this and I asked you to write me an equation? If you have these notes in front of you, do you feel like you would be able to pull that off? How are we feeling about that? Pretty good. Hector, how are you feeling about it? If I gave you a table like this and I asked you to write an equation like this and you have these notes, did you get these notes in your packet? Why don't you go ahead and do that while they're up here? Right. All right, one more time. Sorry, a little bit of motion going on there. How are we feeling right now? If I give you a table and you have those notes in front of you, so what I'm seeing is that about half of us are feeling like I could probably use some practice on this before the test. That's what I see when I see this right now. Like I feel pretty good about it. I get the basic idea, but I'm not confident enough because I haven't done enough problems. Is that a good interpretation? And some of you are like, bring it on, test me right now. I got this. And that's great. That's great. Now I'll tell you, it's gonna get we're gonna update this, right? I told you to leave some space underneath this because we'll kind of add a little bit more depth to it as we go. All right, so our goal for whether we get through 1 or 2 lessons right now, I'm still kind of up in the air, but we're going to go ahead and just start in on it and see how it goes. We're focusing on change today. There's actually another word for this. Does anybody know the other word that we use for M? Slope. Yeah, let's go and write that in over here. And slope is going to be the focus of either this lesson and our next one, or maybe just this one. We'll kind of see how it goes today. What do you guys remember about slope? Up or down? Okay. We have some notes on slope. Maybe we should get some of these right into our notes. What do you think? Rate of change and slope. It's right down below. It's on that same page, right down below. So what did you say? What do you remember about slope? Up or down and oh, so you know about negative and positive slopes? Folks, are we aware of negative and positive slopes? So I'm gonna give you a big hint right now. When we read slopes in this class, we always read it from left to right, the same way you would read a book that's written in English. Not all languages read from left to right, but in English we read from left to right. And if we are going uphill from left to right, we're going to call that a positive slope. And if we are going downhill from left to right, we're going to call that a negative slope. Are you familiar with this idea? Have you seen this before? Positives and negative slopes? And I'm going to tell you that is the #1 source of errors. Okay? This will be the thing that, like the one minor thing that are going to lose people a couple points here and there on a test. Is that it's going to be a negative slope and you're going to graph it as a positive or vice versa. Really easy to forget this. So star next to mine because I want to. What else do you remember about slope? What comes back when you think about slope? What do you think about? Rise over run. How many people have heard that before? Rise over run. Most of us have. Okay. Now we call this something different in high school math. So I'm going to go ahead and introduce something. This is part of the first lesson on slope. Rise is in which direction? Is rise in the X direction or the Y direction? Rise is in the Y direction, correct? Because rise goes up and down, and we know that Y goes up and down. So, and run is in the X direction. Can you write that down for me? Have you seen that symbol before? Do you remember what it's called? Do you remember what it means? The symbol shows up a lot in math. Anybody ever heard of calculus before? Calculus, like many of you are going to take calculus. It's the highest math that we offer at the high school. And it is all about this symbol here. It's a Greek letter. This is actually a letter of the Greek alphabet. Anybody know their Greek? This is delta. This is the letter delta. Delta V. Yeah, delta V. Are you a Kerbal Space Program expert? Awesome. So what it means in the context of slope is change. And it's actually, we pronounce it as change in. So it's the change in Y over the change in X. The delta V is an important concept in rocketry, in rocket physics, and it is how much your velocity changes. So it's and it has to do with how much fuel it takes to make you go from a certain speed to another speed and escape velocities and all that fun stuff. It is. It is. So what else do you guys remember about slope? Anything else? There's a graph. There's a graph of slope, and we'll get to that in just a second. In fact, why don't we get to that right now? Could you guys get to your handout, please? And I want to look at the side that looks like this. All right, let's stick with what we were just talking about a second ago. We're talking about slope is change in y over change in x. So if I looked at this graph right here, and I asked you from this point right here to this point right here, draw those 2 points in for me. How much is my y changing and how much is my x changing? Could you put in some actual numbers to the top and bottom of that fraction? Anybody want to be brave and give me a suggestion for how much y is changing? Let me call in some folks I haven't heard from here. So Jackson, what do you think? In the y direction, to go from this point to this point, how much will I have to change? Yeah, from this point to this point, how much am I in the y direction? First of all, is y left and right or up and down? Up and down. So how much do I need to move up to get from this point to this point? 27. Awesome. Thank you. 27. And they told us that here, but I bet we could have figured it out by looking at this, right? We could have thought to ourselves, what is 58 minus 31? We got 27. Correct? Because those are our two y coordinates. That's how much we're changing to go from here to here. Anybody want to be brave and tell me what you think the change in x is? I'm gonna call on someone. I want to hear some more voices today. Avneet, what do you think? 3. So in the x direction from 4 to 7 is 3. Yes, you're absolutely right. 27 over 3. All right, so that is our slope. Could you do the same thing for me here for number 15? First of all, I want you to write down delta y over delta x. No, it seems kind of tedious to keep writing the same thing down, but we know that that repetition is what's going to help our brains remember it long term. And can you find me some values? Now this time it's not so easy, so we might have to do some counting, or we might want to look at our x and y values along the scale, along the actual axes there. All right, I'm gonna get some input for you here from here on this next one. So I'm gonna call in a couple people. Charlie, what'd you get for your change in y? You said 2. Okay. And change in x user. What'd you get for your change in x? You didn't get anything. Get rid of the headphones for me. I want to make sure you're paying attention. So if I were to look at how far it changes in the x direction, I want you to think about that. I'm going to call on someone else. Victor, what do you get? We think 4. So let's see how we did here. So I'm going to check both of these. So our claim is that our change in y is 2. if I look from this point to this point, my y coordinate is going from a 2 to a 4. Would you agree that my change in y is 2? And if I look from this point to this point, my change in x, my x is going from 0 to 4. We think that's plus 4. I agree. Okay. Look at 16. And I would like you to find me 3 different slopes, one for A, one for B, and one for C. So this time I'm not going to write change in x over change in y each time. We'll just go ahead and put some numbers in there. Find me change in x and change in y for A and B and C and put them right on there. Use these 2 numbers and just pick out which one's going in the next direction. Yeah, it's gonna have a decimal. Okay. Well. Is it 5? 4? One of them might have a decimal in it, fair warning. Where you at?
Actually, that's working quite well.
Yeah, sure. So when I look at this triangle here, we're going to use, this is how much it's changing. That's how much it's changing in this direction. Well, the y change on the top and the change on the bottom. We will come back. So for A, yes, you're right. Okay. You're a little ahead of me. We'll come back to you. Good for you. That's awesome. Good for you. All right. So in walking around, I feel like we're getting pretty good at recognizing that to make a slope, we look at how much it's changing in the x and y. What do you suppose the most common mistake that I saw was? It's really easy to flip it, put the x on top and the y on the bottom, right? Really easy. There are like 3 or 4 of you who made that mistake. Congratulations. You have gotten that mistake out of the way. You learned from it today. You don't have to worry about making it on your test. It's good to make mistakes at the beginning, right? So when we do this, I think it's probably smart every time we do this problem to at least write somewhere on our page change in y over change in x. If you repeatedly write that on your page, it's less likely you're going to make that mistake. So when I do this, I have to ask myself, which one of these is the y and which one's the x? Y is up and down, so that would be 6/4. Y is up and down, this would be 3/2. And C was tricky because what did you have for the change in y for C? 4.5? 4.5/3. All right. You figured something out? What'd you figure out? Okay. Half a block, yeah. Yeah, it's definitely a piece of it, right? We think a third or a half? We're actually going to talk about that in a second. We'll be able to settle this dispute in a moment. All right. Now this is not on there. Folks, I'm going to challenge you here. I'm going to draw a new triangle. It's going to start down here and it's going to encompass both of these. Could you draw me this new triangle? Let's call it D. And this time we need to do some counting. So what's our change in y? What's our change in x this time? So we're going over 6, it looks like. Do you count up and down? You said 9? So 6/9 or 9/6? So it's y over x, so 9/6. All right, now, don't miss this. This is kind of the key piece here. I saw a couple people that had something different written for A. Jada, do you mind sharing what you had for A originally? So Jada originally actually wrote 3/2 for A. Can anybody see why Jada did that? This is awesome, by the way. I already told you you're on the right track. Say that louder. We're reducing. If I asked you to write this fraction on a test, you would know that I'd want you to reduce this, right? And if I reduce 6/4, what would I get? 3/2. Can you reduce 9/6 for me? What would you get if you reduce 9/6? By the way, if you don't remember how to reduce fractions, the whole key is find a number that divides into both of them. What number divides into both 9 and 6? We can divide them both by 3. So divide by 3 top and bottom. And we would get 3/2 again. I wonder what would happen if I reduced 4.5 divided by 3. Do you think that would come out to be 3/2 also? Are you saying if I start, wait, don't miss this. This is good. You're on the money today. If I start here and if I go over, say that again. I go over 2 and I go up 3, I do end up making a triangle and that does fit it right on the line. So here's the big question. If I drew any triangle on this particular line and came up with the slope, is it always going to end up being 3/2 after I reduce it? And the answer is yes. That is what slope is. Slope measures what about a line? Don't miss this, please. What does slope measure about a line? Not sure. Okay. Flip over to the back side. All right, now. Okay. We're like I said, we're feeling our way along here. Look at line A and line B. Look at line A and line B. Don't worry about triangles or anything like that. I don't want anybody counting anything right now. Just look at those two lines and tell me which one has a bigger slope. Can anybody tell me just by looking at those two lines, which one has a bigger slope, A or B? B has a bigger slope because it is steeper. Slope measures how steep something is. Slope measures how steep something is. Now go back to the front side. Would you agree that any point along this line is the same steepness? It's not steeper here than it is here. Every point has the same steepness. So every point has the same slope. Now, this is kind of a key thing, and we're going to get to this a lot more as we get deeper into this. So I'm getting a little bit ahead of ourselves, but if I were to pick and make a triangle that was only 1 unit wide, how tall would it need to be along this line? If it was 1 unit wide, how tall would it need to be? It would need to be 1.5 tall. And I know that because 3 divided by 2 is 1.5. 6 divided by 9 is 1.5. 6 divided by 4 is 1.5. You can try this in your calculator if you don't trust me, but 4.5 divided by 3 is 1.5. 1.5 is our slope here. And it doesn't matter which triangle we draw on it, we're always going to get 1.5. So slope measures how steep something is. How are we doing on time? I think we're going to go ahead and wrap it up here for today. You guys have done an awesome job. We're going to come back. We've done like 1.5 lessons now. So that means when we come back on, when do I see you again? Monday, we'll kind of have a quick wrap up of that second lesson. You'll have a lot more time for homework. But for today, we got a pretty decent chunk. New assignment is 19 through 24. After the bell rings, you can, I'll freeze it so that it's up here.